Hello everyone, my name is Sanchali Parekh and I'm currently pursuing my bachelor's degree in AI and Data Science from Nitya Meenakshi Institute of Technology, Bangalore. Today, I'll be discussing about a topic that's growing more critical every year, that is sustainable water management, techniques, innovations, and future challenges. This project is made under the guidance of Maulya Ma'am, Assistant Professor, Department of Civil Engineering at Nitya Meenakshi Institute of Technology. So, let us begin with our topic. Sustainable water management, techniques, innovations, and future challenges. So, water is something we often take for granted, but as the United Nations has warned, global water demand is projected to outstrip supply by 40% by 2030. That's less than a decade away. In this talk, we'll explore what sustainable water management means, why it's important, some proven and innovative techniques being used around the world, and the serious challenges we face in ensuring water security for future generations. What is sustainable water management? It means using and managing water resources in a way that satisfies our current needs, whether it's for drinking, farming, or industrial purposes, without compromising the ability of future generations to do the same. It's not just about saving water, but about making sure water systems remain healthy and functioning. Our goal here is to strike a balance. We must meet human demands while preserving ecosystems that depend on water. The key challenges include rising water scarcity and increasing pollution, which are affecting every part of the world, whether rich or poor. Importance of sustainable water use. Why is it so important to use water sustainably? The benefits are widespread and can be categorized into economic, environmental, and social benefits. Economically, sustainable water practices reduce water bills and energy costs, improving agricultural yields, and supports industries that relies on consistent water supply. Environmentally, they protect aquatic ecosystems, reduce pollution, and conserve biodiversity. Socially, they ensure fair water access and promote better public health and strengthen the resilience of communities against disasters like droughts and floods. So below are the key reasons why sustainable water use is critical. First is preserving freshwater resources. Freshwater resources are limited, with only 2.5% of the Earth's water being freshwater. Of this, much is locked away in glaciers or deep underground, leaving only a small fraction available for human consumption. Economic benefits. Efficient water use reduces water and energy costs, benefiting household, industries, and agricultural sectors. It is crucial for industries such as energy production, manufacturing, and tourism. Sustainable water practices ensures long-term productivity and economic stability. Next one is public health and hygiene. So, sustainable water management ensures clean water is available for drinking, cooking, and sanitation, which is critical for preventing waterborne diseases and improving public health. Properly treating and recycling wastewater as part of sustainable water reuse helps to reduce pollution and safeguard human health. Reducing environmental impact. Efficient water use reduces the energy required for water transportation and treatment, leading to a reduction in carbon emission. The sustainable water practices help minimize the environmental footprint of water extraction, reducing ecosystem disruption and maintaining natural hydrological cycle. Global water crisis and challenges. Let's look at the scale of global water crisis. According to WHO and UNICEF, 2.2 billion people still lack safely managed drinking water, and as of 2021, 40% of the global population is affected by water scarcity. Climate change is only making things worse. Rising temperatures are increasing evaporation and shifting rainfall patterns, making water supplies unpredictable. On top of that, urbanization and population growth are raising water demands while natural resources like aquifers are drying up. This crisis affects everyone from small villages to mega cities. The global water crisis is one of the most pressing challenges facing humanity today. Despite water covering over 70% of the Earth's surface, only a small fraction is accessible and fresh enough for human consumption, agriculture, and industry. The disparity between water availability and demand is growing, leading to widespread concern about water scarcity and sustainability of freshwater resources. Water conservation techniques. Now let's move on to the techniques. Conservation is the first and most critical pillar of sustainable water management. Water conservation involves reducing wastage and using water efficiently across residential, commercial, and agricultural sectors. Each sector has different needs and challenges, but the underlying principle is the same. We must reduce our consumption and avoid unnecessary losses. Some of the most impactful techniques include low flow fixtures, drip irrigation, water efficient landscaping, leak detection, rainwater harvesting, and more, of which I'll be explaining in the next slides. Low flow fixtures and drip irrigation. First, low flow fixtures. These include faucets and shower heads that use significantly less water than traditional ones. For instance, modern low flow toilets use about 1.28 gallons per flush compared to older models that use 3 to 5 gallons. In large buildings or communities, these small savings add up to thousands of liters every day. Then we have drip irrigation, a smart agricultural technique that delivers water directly to plant roots through pipes and emitters. It minimizes evaporation and runoff, reducing water use by up to 60% compared to traditional methods like flood irrigation. So, the benefits of low flow fixtures include water conservation, cost savings, environmental impacts, and easy installation. What is drip irrigation? So drip irrigation is a highly efficient watering system that delivers water directly to the roots of plants, minimizing evaporation and runoff. It is commonly used in gardens, landscapes, and agricultural applications where water conservation is a priority. Drip irrigation systems consist of tubes, emitters, and a pressure regulated system to ensure that water is delivered slowly, steadily to each plant. Discuss the next technique, water efficient landscaping. So water efficient landscaping helps reduce outdoor water use, especially in dry regions. Xeriscaping, for example, uses drought resistant plants that require minimal watering. Smart irrigation systems that adjust watering schedules based on real-time weather data and soil moisture sensors, preventing overwatering. And simple practices like mulching retain soil moisture and reduce the need for constant watering. These techniques are especially useful in urban areas, helping save water while maintaining green spaces. So, xeriscaping is a specific type of water efficient landscaping focused on designing gardens and landscapes that are highly drought tolerant and require minimal irrigation. The term xeriscaping comes from the Greek word xeros, meaning dry, and landscaping, meaning the use of dry resistant plants and techniques to conserve water. Next is smart irrigation systems. These are advanced watering systems that use real-time data from weather forecasts, soil moisturizer sensors, and landscape conditions to optimize watering schedules. These systems are designed to prevent overwatering and underwatering by delivering the right amount of water at the right time. Next process is mulching, an initial practice for water efficient landscaping. So it is one of the most effective and environmentally friendly methods for conserving water, reducing maintenance, and improving soil health in gardens and landscape. It involves placing a layer of material on the soil surface around plants and garden beds. The material can be organic, like leaves, wood chips, or compost, or inorganic, like stones or plastics. The key principles of water efficient landscaping include selection of drought resistance plant, use of efficient irrigation systems, and soil management to retain moisture. Our next technique is water metering and leak management. So, another major area of water loss is leakage, whether from household pipes or municipal infrastructure. Smart water metering helps track real time usage, detect abnormalities, and encourage conservation. Leak management programs, including regular audits and repairs, can reduce water loss by 10 to 20%. According to the American Water Works Association, think about this. In some cities, nearly a third of water supplied is lost before even it reaches consumers. Fixing leaks is one of the fastest and most effective ways to conserve water. So benefits of water metering include: first, accurate billing. Charges are based on actual usage, preventing over or underbilling. Next is water conservation. Consumers become more aware of their water usage, encouraging conservation. Leak detection. Monitoring usage patterns helps identify unusual consumption, possibly indicating leaks. Next is efficient resource allocation. Helps utilizing predict demand and optimize water distribution. Then leak management. Leak management focuses on detecting and fixing leaks in the water distribution system to minimize water wastage and improve efficiency. Leaks can occur due to aging infrastructure, external damage, or system pressure issues. Benefits of leak management. Water conservation. It reduces the amount of water wasted due to undetected leaks. Next one is cost savings. It minimizes the cost of treating and pumping water that is lost to leaks. It prevents damage to pipes and pumps caused by undetected leaks. Helps meet government and environmental standards for water conservation and management. So, with increasing water scarcity and pressure on infrastructure, the future of metering and leak management will rely heavily on IoT and smart technologies, seamless integration of smart meters, sensors, and AI for predictive analysis and automation, data-driven decision making. Advanced analytics and machine learning will improve leak prediction, system optimization, and resource management. Sustainability focus. Emphasis on reducing water loss, conserving resources, and ensuring more sustainable urban water management. Next method is rainwater harvesting. So rainwater harvesting involves collecting rain from rooftops or other surfaces and storing it for reuse. It can be used for irrigation or even treated for drinking. In rural areas, it ensures a reliable supply during dry months. In urban areas, it reduces pressure on the municipal water system and helps control stormwater runoff. It's a simple, age-old technique that is gaining renewed importance as cities struggle with water shortages. Rainwater harvesting is the process of capturing, storing, and using rainwater for various purposes. It involves collecting rainwater from surfaces like rooftops, pavements, or natural catchment areas, storing it and using it for irrigation, drinking, or other needs. This practice is a sustainable way to supplement traditional water resources and reduce dependency on external water supply. The benefits of rainwater harvesting includes water conservation, cost savings, flood control, and groundwater recharge. It also helps reduce reliance on treated water, decreasing energy consumption associated with water treatment and distribution, and thus reduces the harmful environmental impacts. Agricultural use. It is also ideal for irrigation as it is free from chemicals like chlorine and fluoride found in municipal water. Next water conservation technique is grey water recycling. Grey water recycling means reusing water from sinks, showers, and washing machines, including toilets or kitchen wastewater. It can be treated and reused for toilet flushing, landscape irrigation, or cleaning. It reduces demand for fresh water and decreases the burden on sewage systems. Homes, hotels, and office buildings can all benefit from this system, both economically and environmentally. So, why we should recycle grey water? We should do this because it conserves fresh water, it reduces wastewater, it saves our money, and is eco-friendly. So the typical sources of grey water include bathroom sinks, showers and bathtubs, washing machines, and laundry sinks. Smart irrigation and watershed management. Smart irrigation uses technologies like soil moisture sensors, automatic controllers, and weather forecasts to water only when necessary. It saves water and boosts crop yield. On a larger scale, watershed management is about protecting the entire drainage basin, from hills to rivers, so that water resources are conserved and the pollution is minimized. It involves reforestation, soil conservation, and water recharge strategies that sustain the natural cycle. It improves livelihoods in rural development regions. Smart irrigation and watershed management are completely strategies. Watershed management focuses on supply side, which is conservation and availability, while smart irrigation focuses on demand side, that is efficient uses. Together, they ensure sustainable agriculture, especially in water scarce and climate sensitive regions. The next technique is urban wastewater management. Urban wastewater management is about heating and reusing wastewater instead of simply dumping it. It includes safe water supply, stormwater drainage, flood prevention, and sanitation. Cities are using retention ponds, green roofs, rain gardens, and smart drainage systems to handle floods and reuse water. Wastewater treatment plants can now recover energy and nutrients while producing clean water for reuse. This is crucial for building climate resistant cities. The key components include water supply management, stormwater management, water conservation strategies, and urban flood management. The objectives of urban water management ensures 24/7 access to safe drinking water, provide sanitation and hygiene for all, reduce pollution and protect water bodies, minimize water loss and optimize resource use, increase resilience to climate change and population growth. It saves water and energy and also reduces pollution and flooding. It supports sustainable and resilient cities. Okay, conclusion. Now, to wrap up this topic, sustainable water management is not just an environmental need, it's a human survival necessity. New technologies are improving how we conserve, reuse, and manage water, but the road ahead is tough. We need to deal with growing population, worsening climate conditions, poor infrastructure, and limited funding. What we need is integrated planning, innovative policies, public participation, and most importantly, awareness. We all have a role to play in protecting our most precious resource, water. Water management is a critical component of sustainable development, public health, and environmental protection. The modern techniques such as membrane bioreactors, decentralized treatment systems, and nutrient recovery are transforming how we treat and reuse water. Innovations like IoT-based monitoring, AI-driven process optimization, and energy-efficient treatment technologies are making systems smarter and more sustainable. However, future challenges remain significant, including growing urban populations, climate change impacts, infrastructure gaps, and financial constraints. Addressing these challenges will require integrated planning, community engagement, policy support, and continuous innovation. A future-ready wastewater management system must be resilient, resource efficient, and inclusive, ensuring clean water access and environmental protection for generations to come. So that was all about wastewater management. Thank you.